Hi friends, welcome to Gate Academy. Good morning, Narendra. Good morning, Prachi. Good morning, Shubham. Good morning, Rajiv. Good morning, Abhishek. Good morning. Already there is one like. Why? It's because I am not on time. Sorry for not being on time. Sorry for the delay of 5 to 6 minutes. Uh, so yesterday we were discussing about the design of flexible payments. In design of flexible payments, we have discussed the design parameters. Now we will be seeing the different methods. First one is empirical method. Empirical method. So in empirical method, what you people will see, first one is group index. In empirical methods of design of flexible payments, this is not design of rigid payments, this is design of only flexible payments. The first method in this one is group index method. Group index method. This method you might have seen in your geotechnical engineering also. The same thing, group index method is used over here. Fine. So this method is generally based on index property of the soil. Index property of the soil is that type of property that used for classification of soil, like liquid limit, plastic limit, plasticity index, and percentage finer than 75 microns and all those things. That is group index. Fine. So what you can write over here is this method is based on index property of the soil, index property of the soil index property of the soil index property is the property that is used for classification of the soil, that is used for classification of the soil, like liquid limit, plasticity index, etc. So as per IRC, group index is generally given as 0.2a plus 0.005 AC plus 0.01 BD. This is group index. 0.2 A plus 0.005 AC plus 0.01 BD. What is A, B, C, D? One second, I'll write here. Group index 0.2 A plus 0.005 AC plus 0.01 BD. A value is generally given as P minus 35, B value is generally given as P minus 15, and C value is generally given as WL minus 40, D value is generally given as IP minus 10. It should not be more than 40, this should not be more than 40, this should not be more than 20, this should not be more than 20, where P is the percentage particles what I can say, percentage finer than 75 micron sieve, where P is the percentage finer than particles whose size is percentage finer than 75 micron sieve. If you see in soil classification, we will be using 75 micron sieves, so that if particles, if it is 50% is finer than 75 micron sieve, then we consider it as clay, silt, and if 50% is in a simple way, what I can say is, if this is 75 micron sieve, If this is 75 micron sieve, there are different types of sieves. If this is 75 micron sieve, if more than 50% is retained, if more than 50% is retained, if more than 50% is retained, then it is considered as sand or gravel. Indirectly it is considered as coarse grained soil, right? If more than 50% is passing, more than 50% is passing, then it is considered as fine grained soil. If more than 50% is retained, then it is considered as coarse grained soil. If more than 50% is passing, then it is considered as fine grained soil. So P here is percentage finer than 75 micron sieve, right? Finer means indirectly what is the percentage that is passing through 75 micron sieve. That is the thing, that is P, and WL is the liquid limit. WL is liquid limit, and IP is plasticity index. IP is plasticity index. WL is liquid limit and IP is plasticity index. Fine. So that means the value should not be more than 40. Whatever the value, if you are getting 50, that means you will restrict the value to only 40. Here also you will be restricting the value to 40. Here also you will be restricting the value to 20, 20. Fine. So these are A, B, C, D. Based on this, you will calculate the group index. This is given as per IRC, and higher is the group index. Generally, the group index will be in the range of 0 to 20. Group index will be in the range of 0 to 20. Higher is the group index. 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 Poorer is the quality of soil. Higher is the group index, poorer is the quality of soil. Higher is the group index, poorer is the quality of the soil. That means we make sure that if group index is less, soil is good, then you don't require that much amount of you don't have that much amount of problem in it. You can just add the water content, find the optimum moisture content, and then compact it with the roller. The soil will be ready. But if group index is more, that means indirectly there is more amount of clay and silt over there. Then you have to go for soil improvement techniques. Once if you improve the soil, then only you have to apply the, lay the road on it. Fine. So generally you will find a table. Where group index will be there, thickness will be there. Where group index and thickness will be there. Based on that, you will design the road. Based on group index, you will provide the thickness of the road. Based on group index, you will provide the thickness of the road. So there will be a table. Based on this, you will be providing the thickness of the road. What is the drawback in this? If you ask me the drawbacks in the group index, generally what do you have in a subgrade, sub-base course, base course and surface course, right? In a flexible pavement, there will be subgrade, sub-base course, base course and surface course. Base course and surface course, right? So in this, what exactly you have to do is, if this is subgrade, if all these things are there, you will find out the quality, that is group index of the subgrade. Based on group index of the subgrade means indirectly soil, you will find out the thickness. You will provide the thickness for the layers above this. Are you getting it? The thickness depends on thickness of the layers above this, depends upon the group index of the subgrade. Fine. So That means based on group index of subgrade, you will, let us say we are providing some 20 centimeters thickness or 30 centimeters thickness. The road thickness is 30 centimeters. It does not consider whether you are providing marbles, whether you are providing bitumen, whether you are providing coarse aggregates, fine aggregates, whatever the thing that you are providing, it is not considered over here. You are getting it? That means even though if you provide clay, then also you will provide same thickness. Even though if you provide marbles, then also you will provide same thickness. That means quality of the material is not considered. For both poorer quality and better quality, same thickness of these things is provided. That means we will find out group index of the subgrade. Based upon group index of the subgrade, we will provide the thickness of the pavement, right? So that means based on group index, you will provide the thickness, whether it is, as I said, whether it is marble, whether it is normal coarse aggregates, fine aggregates, or any type of material, you won't consider the quality of the material. For whatever the material, you will be providing same thickness. Fine. That is the major drawback. Major drawback in this method is 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 quality of the material is not taken into account. Quality of the material is not taken into account as same thickness is provided for both poorer and higher quality materials, for both poorer and higher quality materials. Fine. Major drawback in this method is quality of material is not taken into account. Same thickness is provided for both poorer and higher quality materials. Generally, thickness based on subgrade depends on group index, and thickness of the surface course and base course depends upon group index as well as traffic volume. Fine. So the whole thickness you will calculate based on subgrade, and thickness of surface course, base course you will calculate based on GI and traffic volume, and thickness of sub-base course is obtained by total thickness minus surface course and base course. You will get the thickness of sub-base course. So you can take this as the note. The note point would be thickness of pavement depends on group index. Thickness of pavement depends on group index, whereas thickness of surface course and base course depends on group index and traffic volume. And generally type of traffic, volume of traffic. If it is less than 50 vehicles per day, not per hour, VPD, 50 vehicles per day, then it is considered as light traffic. And medium traffic medium traffic if it is in the range of 50 vehicles per day to 150 vehicles per day, and heavy traffic if traffic volume is more than 150 vehicles per day, then it is considered as heavy traffic. If traffic volume is more than 150 vehicles per day, then it is considered as heavy volume. Fine. So, based upon the traffic volume and group index, generally you will provide surface course and base course. The thickness of sub-base course is calculated sub-base course equals to total thickness of pavement minus thickness of surface course and base course minus thickness of surface course and base course. Any doubts in this, guys? So, this is how you will be calculating the thickness of the pavement based on group index method. So, once again, if you see from the starting group index, the method is based on index property of the soil. Index property is that property which is used for classification of the soil. I have given you the formula how to find out the group index, where P is the percentage finer than 75 micron, C 1 liquid limit, WL is liquid limit, IP is the plasticity index. Plasticity index equals to liquid limit minus plastic limit. You might be knowing this, right? So, WL minus WP, plastic limit. So, based on that you will calculate group index. Higher is the group index, poorer is the quality of the soil, and based upon group index it will give you the thickness of what is the thickness that you have to use. So, the drawback over here is whatever the type of it does not consider the quality of the material that is used for construction. Even for the poorer quality and heavier quality, you will be higher quality, you will be using same thickness of the pavement. Fine. So, and the thickness of pavement depends upon group index of subgrade, thickness of surface course and base course depends upon both group index and traffic volume. Thickness of sub-base course is calculated something like this. Any doubts up to here? You can ask me. Do we still use this method? Good morning Nitya, good morning Sindhu, good morning Sujit, good morning Abhishek, good morning Rajiv. सर मैंने टेस्ट सीरीज़ का एक क्वेश्चन किया था जिसमें ए की वैल्यू नेगेटिव थी, तो उसने लेके जीरो लिया था, क्यों जीरो लिया था? फाइन. सो देयर आर 3 dislikes here. Great. And anyway, so you are asking why the a value he has taken it as negative, why he has taken it as 0. The thing is, group index cannot be negative. As I said, group index will be generally in the range of 0 to 20. It should be in the range of 0 to 20. That is the reason he might have taken a equals to 0. It can't be negative. Fine. Do we still use this method? In the field we are not using these methods. Whatever that I am discussing in the class, we are not using any methods in the field. Whatever you are reading right now are just basics. We don't use all these methods in designing things. Fine. So please solve this question. A soil subgrade has following data. A soil subgrade has following data. A soil subgrade has following data. P equals to 60%, liquid limit equals to 45%, plastic limit equals to 20%, find out the thickness of the pavement required above soil grade. Find out the thickness of pavement required above soil subgrade. Fine. GI thickness 10, 15, 20, 30 centimeters, 45, 62, 70, 90. So fine guys, please solve it. Just a minute, I'll get back to you. Whenever I say thickness of the pavement, Rajiv, the thickness of pavement is, we don't consider soil subgrade. Subgrade means I have already told you, subgrade is like normal soil. On the soil you provide the thickness. Thickness will consist of subbase course, base course, surface course. That is the meaning of it. We are calculating the group index of subgrade, and based on group index of subgrade we will provide the thickness of all these things. So thickness of pavement indicates subbase, base and surface course. And Narendra, what is the range of good, poor and all those things? I think it should have been discussed in your geotechnical engineering. Go through that. I think it is even more from transportation engineering point of view. I have discussed whatever that is important over here. Okay, so go through that. Solve this question. What is the thickness of the pavement that is required? .8 centimeters, 68 centimeters. What is the answer, guys? Only one person has answered the question. What about the other guys? If you want the classification also, it's actually type of soil based on group index and type of soil. If you ask me, if group index is 0 to 1, then I will say it is good. From it is 2 to 5, it is fair. 5 to 9, poor. 10 to 20, very poor. Fine. I think the range would be something like this: group index and type of soil. Okay. Now, how we will be solving this question? Group index is generally given as 0.2a plus 0.005 AC plus 0.01 BD, right? So, A value, A equals to P minus 35, right? Percentage finer minus 35, what is the value? Value is 60%, that is given to you. 60 minus 35 that equals to 25, not greater than 40%. Therefore, A equals to 25. Fine. B equals to P minus 15. P is 60 minus 15. I said it should not be more than 40%, right? You will get it as 45, which is more than 40%. Therefore, B equals to 40%. You will restrict B to 40%. C equals to liquid limit minus 40. Liquid limit is how much? 45 minus 40, that equals to 5. D equals to IP minus 10, which should not be more than 20%. IP value is how much here? Liquid limit minus plastic limit. Liquid limit is 45, plastic limit is 20, so IP would be 25. D equals to 25 minus 10, it should not be more than 20%. So, D you will be getting it as 15%. So, this is A, B, C, D. Based on this, how will you calculate group index? Group index equals to 0.2A, 0.05 AC plus 0.005 AC plus 0.01 BD. So, 0.2 multiplied with 25 plus 0.005 multiplied with 25 multiplied with C. C is 5. C is 5 plus 0.01 B. B is 40, D is 15. B is 40, D is 15. So, the group index value is, this is 5. What is this value? 5 and 125 into 5 is 625. 625 into 10 to the power of minus 3. So, 5 plus 0.625 plus 60, that is 6. I think it is 11.625 you will be getting, right? 11.625. Fine. 11.625 means it will be in this region. So, that means you have to do linear interpolation. Just do the linear interpolation. For 10 it is 62 centimeters, for 15 it is 70 centimeters, for 11.625, what is the value? Let us say if it is x, x would be equals to 62 plus 70 minus 62 multiplied with 15 minus 10 upon 11.625 minus 10 multiplied with 11.625 minus 10 upon 15 minus 10. So what is this value? 1.625 upon 5 multiplied with 8. One 1.625 multiplied with 8 upon 5 plus 62. That is approximately 64.6 centimeters. This is the value of x, that is thickness of the pavement. Thickness of the pavement. Thickness of the pavement is 64.6 centimeters. Thickness of the pavement is 64.6 centimeters. Fine. Any doubts in this? You can ask me. What? क्या नीचे होगा? This is just a linear interpolation here. For 10 the value is 20, for 50 the value is 72. What is the value for 11.5? I am asking. This is for 10, 11.625, 15. For this the value is 62 and for this the value is 70. What is the value for this? I am asking. So what is your doubt in this? This is the answer. Any doubts? You have done a mistake, fine, well and good for you. Don't repeat those mistakes. Any doubts in this, guys? Any doubts? No doubts? Fine, well and good. Next one we'll be seeing is CBR method, right? Yeah. Next method is California bearing ratio method. California bearing ratio. California bearing ratio method, that is CBR method. California bearing ratio method, CBR method. California bearing ratio method, CBR method. In California bearing ratio method, what exactly you will be doing? In this, you will be taking a soil sample. You will be taking a soil sample in a vessel. You will be taking a soil sample in a vessel, and you will apply the load on the soil sample. You will apply the load on the soil sample. The diameter of this hammer is generally taken as 5 centimeters. 5 centimeters. There will be soil sample here. there will be some aggregates on top of it. Just for the compaction effect, you will be giving this. So this is 150 mm and this one is 127 mm. Fine. So generally you will be taking a soil sample in a vessel and you will be applying the load at the rate of penetration of 1.25 mm per minute. Rate of penetration as 1.25 mm per minute. Rate of penetration is 1.25 mm per minute. So if you keep on applying the load at which there is a penetration of 2.5 mm or 5 mm is noted. The load at which 2.5 mm load at penetration of 2.5 mm and 5 mm is noted. So that means you will keep on applying the load at the rate of penetration of 1.25 mm per minute, and slowly when you keep on applying the load, there will be the load at which the penetration, or that means indirectly the settlement or the penetration is 2.5 mm and 5 mm. The load at these type of penetrations is noted and a graph is drawn. Between penetration and load. A graph is drawn between penetration and load. Fine. So at 2.5 mm penetration, what is the load you will be seeing? At 5 mm penetration, what is the load you will be seeing? This is 5 mm penetration, this is 2.5 mm penetration. What is the load? If I say this is P1 and P2, that is also taken as load carrying capacity. So based on this, CBR, California bearing ratio, California bearing ratio is generally given as California bearing ratio. CBR is generally given as load carrying capacity of soil sample at 2.5 mm or 5 mm penetration upon load carrying capacity of standard aggregates at 2.5 mm or 5 mm penetration. 2.5 mm or 5 mm penetration. So this is a load carrying capacity of standard aggregate. Standard aggregate means instead of soil sample over here, I'll be using the standard aggregates of size 20 mm or 40 mm depending upon the site conditions, and load carrying capacity of the standard aggregates, that means you'll keep on applying the load and the failure, the load at which there is 2.5 mm penetration or 5 mm penetration is considered, and that is taken over here. Fine. So generally if you ask me why 2.5 mm, 5 mm is, we don't consider more amount of settlement. We don't want more than 5 mm or 2.5 mm of settlement. So that is the reason we are considering 2.5 mm and 5 mm. This is as per IRC. Fine. So this is load carrying capacity of soil sample at 2.5 mm or 5 mm penetration. Generally, if you ask me this, that is load at 2.5 mm penetration load, penetration or settlement load at 2.5 mm, generally load would be 1370 kgs. Standard load, if nothing is mentioned in the question, then it is 1370 kgs. This is 2050 kgs, and this one, what is the dia over here? Dia over here I have given to you as 5 centimeters, right? Dia of this one is 5 centimeters. Then what would be the stress? Stress, how will you calculate? Stress would be equals to 1370 upon pi by 4 multiplied with 5 centimeters, that is 5 square. That is 5 square, and this one is also 2050 upon pi by 4 multiplied with 5 square. So the values would be somewhere around, values would be 1370 upon, this will be approximately 70 kgs per centimeter square, and this one would be 105 kgs per centimeter square. So in the examination they can ask you anything, it can be stress or it can be area also. So out of these two things, this is given as 70 kg per centimeter square, 105 kg per centimeter square. This is the stress. This is standard load. Once again I am saying this is standard load. That means this is this value, not this value. Fine. And generally, so if you are asking me CBR value, CBR equals to P1. P1 is penetration at 2.5 load carrying capacity of soil. P1 is load carrying capacity of soil at 2.5 mm penetration, right? At 2.5 mm penetration, and this is equals to, what I can write is, I'll write maximum of P1 upon 1370 if it is in kgs. This is at 2.5 mm penetration, and P2 upon 2050 kgs. This is at 5 mm penetration. So maximum of these two things is considered as CBR. Fine. Maximum of these two things is considered as CBR. Generally 2.5 mm penetration will, CBR at 2.5 mm penetration is more than CBR at 5 mm penetration. If you by chance are getting CBR at 5 mm penetration is more than CBR at 2.5 mm penetration, then you will repeat the test, and once again you are getting the same value, then you will consider whatever that is maximum. Okay. Generally this should be more than this, but if this is more than this, you will repeat the test, and you will consider whichever is maximum. Okay. Generally CBR at 2.5 mm is more than CBR at 5 mm. If CBR at 5 mm is more than CBR at 2.5 mm, then repeat the test, and consider and use whichever is maximum. Maximum. and use whichever is maximum. Okay. So this is how you will be calculating CBR. Fine. Generally the average of three values, the average of minimum three values, the average of minimum three values the average of minimum three values, the average of minimum three values is considered, the average of minimum three values is considered, the average of minimum three values is considered as CBR value. The average of minimum three values is considered for CBR. That means the test is repeated for 3 times and average of all the 3 values is considered as CBR. Fine. So these are the things that you should remember. Fine. And when I am drawing the graph, between load and penetration, when I am drawing the graph between load and penetration, when I am drawing the graph between the load and penetration, generally the graph has to be like this. The graph has to be like this, but it will not be like this. This is how the graph would be. Initially there will be some concavity and after that there will be convex. This is ideal graph. This is ideal graph. This is actual graph. This is actual graph. This is ideal graph and this is actual graph. Fine. So this is why there is the concavity over here is, why there is concavity over here is, what is the reason for initial concavity? If you ask me, if you see the contact between the soil and the hammer, the contact between the soil and the hammer will not be generally perfectly smooth or it won't be straight. So there will be some unevenness initially, right? So until the time the contact will be perfectly straight, there will be some the data will not be perfectly correct. That is the reason since the contact between the plunger and the soil sample is not perfectly smooth and straight, there will be initial concavity. After some time it gets adjusted itself and it becomes perfectly straight like this. There won't be some unevenness like this. Like initially it moves like this and finally after some time it will be moving constantly. Fine. So that is the reason for initial concavity. Initial concavity. So the reason for initial concavity is, the reason for initial concavity is, the reason for initial concavity, the reason for initial concavity is, the reason for initial concavity is, this is reason for initial concavity is the contact between plunger, the contact between plunger and soil surface is not perfectly smooth, initially. It's not perfectly smooth initially. It's not perfectly smooth initially. The reason for initial concavity is contact between the plunger and soil surface is not perfectly smooth initially. Fine. So this is the reason for it. Finally, after all these things, once you calculate the CBR value, how you are going to find out the thickness? Thickness is generally given as under root of 1.75 upon CBR in percentage minus P upon P pi, minus P upon P pi. That means small p is stress, capital P is the load carrying capacity. So generally P equals to small p into pi A square. So that is P upon P, pi would be A square. Fine. So, this would be equals to under root of 1.75 on CBR in percentage minus A square. This is how you will calculate the thickness of the pavement. Thickness of pavement. Here also if you see, this is first you will calculate the CBR of the subgrade. Based upon CBR of the subgrade, you will calculate the thickness of the pavement. That means whatever the quality, here also the quality of material is not considered. Quality of the material above the subgrade is not considered. Quality of material above the subgrade is not considered. That means if this is soil subgrade, subbase course, base course and surface course, soil subgrade, subbase course, base course and surface course, base course and surface course. Here also the quality of the material, provided above the soil subgrade is not considered. Whatever the quality, whether it is poorer quality or higher quality, you will be providing same amount of thickness. You will be providing same amount of thickness. Okay. So, the drawback of CBR method is the drawback of CBR method is it will not consider, the drawback of CBR method is it will not consider the quality of the material. It will not consider the quality of the material. Same amount of thickness is provided for both poor quality and higher quality materials. For both poor and higher quality materials. That means if you are using marbles also, you will provide same thickness. If you are using stones also, you will provide the same thickness. If you use sand also, you will provide the same thickness. So, it will not consider the quality of the material in the consideration. Fine. For both the quality, it will be providing same amount of thickness. Fine. So, any doubts in this, you can ask me. Small p is indirectly stress. Small p is indirectly stress. P upon p pi, small p is indirectly stress. Sorry. This is P, 1.75 P upon CBR percentage, and CBR should not be more than 12%. Remember this. CBR should not be more than 12%. This formula is applicable only if CBR is less than 12%. P is the load carrying capacity of the soil, or I can also say load applied. You can take in kgs, and then A is the dia of the plunger, in centimeters. Finally, you will get thickness in centimeters only. Dia of the plunger in centimeters. This is the load applied upon the stress that is developed. Simple. Fine. Any doubts in this? No doubts? So, take a question. CBR test was conducted. CBR test was conducted. CBR test was conducted. CBR test was conducted on a soil subgrade. CBR test was conducted on a soil subgrade. On a soil subgrade, and following results were obtained. And following results were obtained. CBR test was conducted and following results were obtained. Penetration load 2.5 mm 60 kgs, 5 mm 82 kgs, 60 kgs, 5 mm 82 kgs, 2.5 mm 60 kgs, 5 mm 82 kgs. Following materials are required to be used over soil subgrade. Following materials are required to be used over soil subgrade. Following materials are required to be used over soil subgrade. Compact soil, CBR equals to 6%. Poorly graded gravel, well graded gravel. Poorly graded gravel, CBR equals to 12%. Well graded gravel, CBR equals to 60%. Well graded gravel, CBR equals to 60%. Bituminous surface of thickness 4 centimeters. Bituminous surface of thickness 4 centimeters. Design the pavement using CBR. Design the pavement using CBR if wheel load is 4100 kgs and small p would be equals to 70 per centimeter square. So please find out. Design the road means just find out the thickness of pavement that should be provided on the top of it. Akash Shukla, good morning. After a long time I am seeing you. Anyway, this is the question. Once again, please go through the question and solve it accordingly. Try to understand the concept. Ah, thank you, Bhaskar, and if possible please solve the question. Narendra has given some answer 40.27 centimeters. What about the other guys? What is that 40.25 centimeters? Do it properly. Try to understand the question and then attempt it. What is that 40.25 centimeters you are saying? Sorry. So what exactly you will be doing here is CBR test was conducted on a soil subgrade and following results were obtained. Penetration load. Following materials are required to be used over soil subgrade: compact soil, poorly graded gravel, well graded gravel, bituminous surface course of thickness 4 centimeters. All these things has to be provided, right? And then what he is saying is design the pavement using CBR as CBR if V load is 4100 kgs and small p stress is given as 70 kgs per centimeter square, right? So first accordingly, what first you have to understand what exactly is provided over here. Initially Sir, you said there will be sub-base course, base course. It's not necessary that it has to be provided like that only. There will be soil subgrade here, soil subgrade here. So that means some soil, like land is there. On the top of the land, you will be providing some compact soil. Just soil will be provided. Next, on the top of it, there will be poorly graded gravel. Poorly graded gravel. Onto the top of it, there will be well graded gravel. Well graded gravel. And onto the top of it, I will be providing some bituminous. I will be providing some bituminous course. I will be providing some bituminous course. Okay. So, this is the thing, right? So, soil subgrade, compacted soil, poorly graded. Sir, here sub-base course, base course, surface course, it is not like that. That is an idea, general idea. So, generally you can give any layers also, but you should know which layer is provided where. Generally first soil is provided. When you going to the top, the quality has to increase. So, compact soil, after that there will be poorly graded gravel, there will be well graded gravel, on the top of it there will be bituminous course. So, first you should calculate what is the CBR for soil subgrade, so that you will get this total thickness. Fine. So, how we will calculate CBR for soil subgrade? CBR for soil subgrade. CBR for soil subgrade equals to CBR for soil subgrade equals to maximum of P1 upon 1370 and P2 upon 2050, maximum of these two things. So, maximum of P1 upon 1370 is how much? P1 upon 1370 is, P1 is how much? 60 kgs, 82 kgs. This is 60 and this is 60 upon 1370. This is 82 upon 2050. Give me the answer in terms of percentages. So, what is this percentage? This is 4.38%, and what is this percentage? 4%. 4%. You have to take maximum of these two things. Since you get maximum over here, then it is correct only. Therefore, CBR equals to 4.38%. This is for soil subgrade. This is for soil subgrade. And now thickness. Thickness of pavement. Thickness of pavement over soil subgrade, over soil subgrade. Thickness of pavement over soil subgrade equals to under root of 1.75 multiplied with P upon CBR in percentage minus P upon P pi. So, that is equals to under root of 1.75 multiplied with 4100 upon CBR in percentage is 4.38 minus 4100 upon 70 multiplied with pi. So, the value would be so this you will be getting it as 40.24 centimeters. You will be getting this as 40.24 centimeters. This is in centimeters. This is also in centimeters. So, you will be getting 40.24 centimeters. This is what? Thickness over soil subgrade. Thickness over soil subgrade. Fine. That means this whole thing is 40.24 centimeters you will provide. Now, he has given CBR of compact soil also. If you consider CBR of compact soil, then you will get the thickness over the compact soil. Okay. So, thickness over the compact soil, what will be the value? Thickness over compact soil, thickness over compact soil. So, thickness over compact soil equals to 1.75 P upon CBR in percentage minus P upon P pi, right. So, under root of 1.75 P is 4100 upon CBR. CBR for compact soil is given as 6% minus 4100 upon 70 pi, right. So, the value would be 34.31 centimeters. This is 34.31 centimeters, right. So, 34.31 centimeters means this whole thing is 34.31 centimeters. If this is 40.24, this is 34.31 centimeters. What would be the thickness of compact soil then? This minus this, right. Thickness of compact soil is thickness of compact soil equals to 40.24 minus 34.31. .93 centimeters. 5.93 centimeters, that is thickness of compact soil. Next, next what else is given to you? CBR of poorly graded gravel is given to you, that is 12%. If I use that CBR of poorly graded gravel, then I'll get thickness above or thickness over poorly graded gravel. Thickness over poorly graded gravel, if I calculate this, that would be equals to under root of 1.75 P upon CBR in percentage minus P upon P pi. So, that is equals to 1.75 into 4100 upon 12 minus 4100 upon 70 pi. The value would be 24.07 centimeters. 24.07 centimeters. That means this one is 24.07 centimeters. This thickness is 24.07 centimeters. Then what would be the thickness of poorly graded gravel? That is 34.31 minus 24.07, you will get thickness of poorly graded gravel. So, what would be this value then? Thickness of poorly graded gravel, thickness of poorly graded gravel is 34.31 minus 24.07. So, this is equals to 10.24 centimeters. Very simple. This is 10.24 centimeters. Now, if you see what is the CBR for well graded gravel, that is 60%. I told you that equation, whatever this equation, this is here. This equation is valid only if CBR is less than 12%. If CBR is more than 12%, that equation is not valid. Since that equation is not valid, you can't use that equation. Then how you will be calculating this is, thickness of bituminous cores is already given 4 centimeters. If thickness of bituminous cores is given as 4 centimeters, this is already given as 4 centimeters, then what would be the thickness of well graded gravel? That is 24.07 minus 4, 20.07 centimeters. This is thickness of poorly graded gravel, this is thickness of well graded gravel. Bituminous course is already given to you. So what I have done, whenever I am saying CBR of percentage is given, CBR of soil subgrade we have calculated based on the thickness above soil subgrade we have done. You don't think that always there should be sub-base course, base course and surface course. It is not necessary that it has to follow the same rule. There can be n number of layers in that. The quality keeps on increasing when you are going upwards. So first soil subgrade, on the top of soil subgrade you will provide compact soil, on the compact soil you will be provided poor graded gravel, well graded gravel, bituminous course. Right. So we have calculated CBR of soil subgrade and we found out thickness as 40.24 centimeters, and we know the CBR of compact soil that is given to us in the question as 6%. Based on that we have calculated this as 34.31 centimeters. Thickness above soils compact soil, therefore the thickness of compact soil is 5.93 centimeters. Similarly, we have calculated thickness above poorly graded gravel, we got this as 10.24 centimeters, and thickness above well graded gravel we can't calculate. Why? Because this is CBR is given as 60%. That formula is applicable only for CBR, not more than 12%, and thickness of bituminous course is given to you as 4 centimeters. So finally, based on that we have calculated thickness of well graded gravel. Fine. So this is the thickness, this is how you are going to design the pavement. Fine. Any doubts in this? You can ask me. Akash Shukla, no doubts. What about the other guys? If you are having any doubts, you can go ahead and ask me. See, this load is like load that is given to you. It's not average wheel load, it is total wheel load. It's like two wheel loads, 2050, 2050, 4100 kgs, and generally P will not be this much high. This is pressure, contact pressure or tire pressure. P is indirectly stress, or I have this is generally in the range of 7 kgs per centimeter square. Here whatever that is small p that I have given, this is contact pressure or tire pressure. Generally what would be the range of contact pressure or tire pressure? That would be around 7 kgs per centimeter square. So if nothing is mentioned, you will consider contact pressure or tire pressure as 7 kgs per centimeter square. If something is mentioned in the question, use that value. Okay. Since here it is 70 kgs per centimeter square, but it will not be up to that much. So P, you can take it as contact pressure or tire pressure. Generally units will be in kgs per centimeter square. This is small p, capital P is the load applied or wheel load. Wheel load that is applied over here is 4100 kgs. Any doubts, guys? No doubts? Fine. So today we have discussed group index method, CBR method. I want to discuss modified CBR also, but it takes a decent amount of time, and that is important topic that I will discuss later. So tomorrow we will be seeing modified CBR method and California resistance value method and triaxial method. So maximum number of things I will try to complete tomorrow. Fine. So with this I am closing this session. If you are having any doubts, you can go ahead and ask me. If not, this is Karthik Mandalapu signing off. Have a nice day.